ID standard for binary floating point representation. Arithmetic format. All the mandatory operations defined by the standard are supported by the format. The format may be used to represent floating point operands or results for the operators described in the standard. Sa arithmetic format naman, pwede i-represent ang floating operands or sa mga results para sa operations na dinidescribe sa standard. Basic format. This format covers 5 floating point representations, 3 binary and 2 decimals. Encodings are specified by the standard, in which can be used for arithmetic, and is one of the basic formats is implemented in any conforming and communicator. Ang basic format naman daw ay covers 5 floating point representation, 3 binary and 2 decimal, kung saan ang mga encodings ay specified na tatlong standard na pwedeng gamitin sa arithmetic. Interchange format. A fully specified fixed left binary encoding that allows it interchange with different backdrops that can be used for structure. Ayan.
Batian, tawag ka batian.
Picturean nyo na lang. Picturean nyo na lang.
Agalin niyo sa inyo. Picturean niyo, agalin niyo sa inyo.
Iba ba tayo sa
Hindi, explain ko yan. Meron ako kasi. Malapit ka na matapos. Bawi. Yun. Ano guys? Para mahiling ako sa'yo para pinaligay ko sa'yo. Umusok mo. Okay. Good morning. Good afternoon class. Before I start, I will introduce myself. My name is Jojo from Los Angeles, California. Let's proceed. And kinatawa. Malamig ito na. Floating point arithmetic. Floating point operations produce. Ayan. Boy, ano yung boy? Kasi mo. Ano na these conditions? Boy, ano yan? Ayun na pala yun. Ito. Explain natin yung nga pala yan. Floating point ay yung exponent overflow. Exponent overflow, a positive exponent exceeds the maximum possible exponent value. Exponent underflow, a negative exponent is less than the minimum possible exponent value, e.g. negative 200 is less than negative 127. This means that the number is small represented and it may be reported as zero. Underflow in part B regarded as negative overflow. The exponent of floating point value, for example, if the exponent part can represent value from negative 128 to positive 127, then a result is a value less than negative 128 may cause underflow. Significant underflow. In the process of aligning significant digits, may flow of the right and of the significant as we shall discuss some form of rounding is required. Significant overflow. The addition of two significant, the same sign will result in carry out of the most significant group. Is getting fixed by realignment as we shall explain. Floating point numbers and arithmetic operation. Let's say, for example, in multiplication, yan nakikita yung yung saladin niya. Pa-picture na lang kung gusto nyo picturean. Kung gusto nyo pumasa.
Paliwanag ko na lang dito.
Huwag gano'n. Yun!
Kaya ba nangyari yun?
Nangyari yan dahil sa sa gravity ng Earth. Ay, bakit? Okay na? Enjoy lang natin to, guys. Okay na? Addition and subtraction. They are four basic steps of the algorithm for addition and subtraction. Ito yung apat na papaliwanag natin sunod-sunod. Check for zeros. Phase 1. Zero check because addition and subtraction are identical except for a sign change. The process begins by changing the sign of the subtrahend is the subtract operation. Next, either operands is zero, the other reported as the result. Ayos naman. Phase 2. Significant alignment. The next phase is to manipulate the numbers so that the two exponents are equal. Phase 3. Addition. Next, the two significant are added together taking into account their signs because the signs may differ. The result may be zero. An exponent overflow could form as a result. This would be reported and the operation phase 4. Normalize the result. Normalize the final phase. Normalize the result. Normalize consists of the shifting significant digit left until the most significant digit. Bit or 4 bits for base 16 exponent. In non-zero, each shift causes a decrement of the exponent and thus could cause an exponent over underflow. Finally, the result must be rounded off and then reported we differ as discussion. The rounding until after a discussion of multiplication and division. Floating point and subtraction. Ay, magpala, wait lang. Papaliwanag ko yan. The typical flowchart is shown in figure 10.22. A step-by-step narrative highlights the main function of required for floating point addition and subtraction. For addition and subtraction, the two operands must be transferred to register will be used by the ANU. if the floating point format includes an implicit significant bit that must be made explicit for the operation. Let's say, for instance, for addition, if the value of x is 0 and so y is material condition to say and return. We first consider multiplication illustrated in figure 10.23. First, either operand is 0. 0 is reported as result. The next step is to add the exponent. If the exponents are stored in base from the exponent sum would have double the base. Thus the base value must be subtracted for the sum. The result would be either an exponent overflow or underflow, which could be reported ending the algorithm if the next exponent of the product is within the proper range. The next step is to multiply the significant taking into account their signs. The multiplication is performed in the same way as for integers. In this case, we are dealing with a sign magnitude representation, but the details are similar to those for two complement. Representation, the product will be double the length of multiplier and multiplicand. The extra bit will be used during rounding. After the product is calculated, the result is then normalized, the rounded as was done.
38 po ba natin?
For addition and subtraction. Note the normalized could be resolved in exponent underflow. Finally,
Nakatawa mo isa ako.
teka, malagpas na ako. Ay, di pa. Di pa pala. Apat nga pala yun. Finally, let us consider the flowchart for division in figure 10.24. Again, the first step is testing for 0. If the divisor is 0, an error report is. Another details that affects the precision of the result is rounding policy. The result of any operation of the significant is generally stored in longer register. When the result is put back into the floating point format, the extra bit must be eliminated in such a way as to produce a result that discloses the extra result is process in called rounding. A number of techniques have been explored for performing rounding. In fact, the IEE standard list for alternative approaches round to nearest, the result is rounded to the nearest representable number. Round to nearest is the default rounding. mode listed in standard and is defined as follows. The representable value nearest to infinity
Malapit na matapos.
traces result shall be delivered. The result is rounded up toward plus infinity. Issued or the result is set to infinity depending on the implementation A divided at of zero result in zero. Next, the divisor exponent is subtracted from the divided exponent. This remove the base which must be added back in. Tests are then made for exponent underflow or overflow. The next step is divide the significant. This is followed with the usual normalization and rounding. Precision consideration. Dimension that prior to a floating point operation, the exponent and significant of each operand are loaded into allo register. In the case of the significant, the length of the register is almost always greater than the length of the significant, plus implement B. The register contains addition bits called guard bits, which are used to pad out the right end of the significant with zeros. The use of guard bits. The reason for the use of guard bits is illustrated in figure 10.25. Consider numbers in the arithmetic format which has a 34-bit significant included in plane 1B. To the left of the binary point, two numbers that are very close in value are x equal 1000 x to raise positive 1 and y negative 1.111. If the similar numbers is to be subtracted from the larger, it must be shifted right one is aligned. The exponent is shown in figure 10.25a. In process y, uses one bit of significant. The result is 2 raised to the negative 22 power. The same operation is repeated in part B with the addition of garbage. Now, the significant bit is not lost due to alignment. And the result is 2 raised to the negative 23 power. A difference of factor of 2 from the previous answer when the radius is 16. The loss of position can be greater as figure 10.25c. And we show the difference can be a factor of 16. Wait lang. Round toward, the result is rounded down toward negative infinity. The next two options, rounding to plus and minus infinity, are useful implementing a techniques known as interval arithmetic. Interval arithmetic provides an efficient method for monitoring and controlling errors in floating point computation by producing two values for each result. The two values correspond to the lower and upper endpoints of interval that contains the true results, the wide of the interval, which is difference between the upper and lower endpoints, indicates the accuracy of the result if the endpoints of an interval are not representable. Then the interval endpoints are rounded down and up respectively. The last part is round toward zero. The result is round toward zero. The final is specified in standard is round toward zero. This is simple. Termination. The extra bits are ignored. This certain the simplest techniques. However, the result is the magnitude of the truncate value is always less than or equal to the more traces originally value producing a consistent base. Towards zero in the operation, this is mysterious base because it affects every operation for which there are not zero bits. I is standard for binary floating point. I 754.
Devon,
Ito yung
ikaw na picture.
Ayun yung hindi niya explain. Dito natin
Devon, kailangan mo.
Goes 754 goes beyond simple definition of a format to lay down specific practice and procedures. So that floating point arithmetic produce uniform predictable result dependent of the hardware platform. One aspect of this has already been discussed, namely rounding. This subsection looks at their other topics, infinity, nulls, and subnormal numbers. Infinity arithmetic is treated as the limiting phase of real arithmetic. The infinity values given the value of interpretation. Every infinity number, with the exception of the special case discussed subsequently, any arithmetic operation involving infinity gets the obvious result. For example, 5 plus double parenthesis negative infinity equal positive infinity. Since the two value corresponds, the lower and upper endpoints of an interval contains the two results. Picture nyo pa ba?
Yan. Consider.
Napadarami ka naman. Kasi nakalagay dito eh.
Kasi namin.
Di ba? Kaya lang yun. Sa akin lang yun. Share ko na lahat sa inyo. Wala na akong masatago. Okay na. Tweet and signaling nonce. A nonce is a symbolic entity encoded in floating point format, of which there are two types: signalings and with a signaling nonce. Signals and invalid operation exception whenever it occurs as a operation.
Sagip pa kami.
Oo, kayo.
God, wala.
Ay, yeah, sampung 3. Ah, sasagay mo na. Pakat na. Normal numbers. Subnormal numbers are indicated in item 754 to handle case of exponent overflow. Press. Underflow pala. Passive.
Ngaling na ka.
Kaya nga, bawa ko sa telefon.
Dini.
The effect of item 754 subnormal numbers. When the exponent of the result becomes too small, a negative exponent with too large a magnitude, the result is subnormal by right shifting the function of incrementing the exponent for each shift until the exponent is within a representable range. The use of subnormal numbers is referred to as gradual underflow. COON81. Without subnormal numbers, the gap between smallest representable zero numbers and zero is much wider than the gap between the smallest representable zero numbers and the next larger number. Gradual underflow is the gap and reduce the impact of exponent under flow to a level comparable with round off among the normal numbers. And that's all. Thank you.
Ready ko ng quiz. One up,
Halo ka,
Mag-quiz yung may plus, palagay na yung...
Yeah!